Hey, I tweeted this video yesterday and I had a few people asking me how I made it. So in this video, I'm going to explain that. If you didn't see the tweet, this is what it was about. Basically, we have a grid of points and we're projecting it onto a sphere. So if I walk around, this is what it looks like. And so you'll see like the grid points that are near to me, they're near to me on the bottom of the sphere, and the points that are far away, they're at the top of the sphere all bunched up. Looks pretty cool. Alright, so how did I do it? I'm going to explain to you the 2D case, but it sort of up-dimensionalizes to the 3D case. Basically what we have is a circle, and we have these evenly spaced points on a line. And what we want to do is draw vectors from the top of the sphere to the points, and then we want to see where do these vectors cross the circle. That's our goal. Alright, so let's just look at one of them. And there are two things that we're given in this problem. We have this vector, and we also have the height of the ball. So the height of the ball is going to be this length here. And using that, we're going to calculate this blue point. So the first thing, actually let me shrink this, I'll just put it in the corner. So that's what we're thinking about. The first thing that we want is this angle, we'll call it theta. And for this, we're doing this in the 2D case, but for the 3D case, we're going to be working with 3D vectors. So I'm just going to treat this like we're working with 3D vectors. And in the way that you calculate an angle between two 3D vectors, what you do is use the dot product. And we're going to use the dot product between this blue vector and the unit down vector. So this is this black vector here. That's the down vector with length 1. So let's call this v, just for simplicity. So the dot product between v and the down vector is going to be this. So we're going to go v dot the down vector, that's going to be 0, -1, 0. And that's going to be the magnitude of v times the magnitude of the down vector, which is just 1, times the cosine of theta. So that's how you get the angle in there, is with the cosine of theta. So let's compute this dot product. So if we call this v, this will be the vector vx, vy, and vz. Then if we compute the dot product, we get vx times 0 plus vy times -1 plus vz times 0. And then on the right-hand side, we just get v, the magnitude of v, times cosine of theta. All right, so let's simplify a bit here. So this will be negative vy is equal to the magnitude of v cosine theta. All right, and then just because we want only the theta, we'll do the arc cosine of negative vy over the magnitude of v. So that is theta. That's the first thing that we want. The second thing that we want is this red, oh boy, that red distance there. And to do this, we're going to use something called Thales' theorem. So what Thales' theorem says is that if we have a diameter of the circle and a point on the circle, then if we inscribe a triangle, then this angle here is necessarily going to be a right angle. So that's Thales' theorem. All right, so let's call the hypotenuse of our triangle h, and this is the length that we want. Let's call that a. So we have theta. Using this, we can say that the cosine of theta is a over h. Or in other words, a is h cosine theta. Cool. Now you'll notice that this theta here comes from the arc cosine, and we're taking the cosine of it. So in special cases, if you take the cosine of the arc cosine, you just get back that value. It doesn't always work. It only works, I believe, when this value here is between 0 and pi. But in our case, that is true. It is going to be between 0 and pi, because an angle between two vectors can only range between 0 and pi. Something like that. I think that's the logic there. Okay, so in other words, if we're going to take the cosine of this angle, it's going to be the cosine of the arc cosine of negative Vy over magnitude of V, which simplifies to h times negative Vy over magnitude of V. And something else to notice is that this negative Vy, that's this length here, which we already have as h. So again, we can simplify a small bit, so we get that a is going to be h squared over the magnitude of V. Great, so we're almost there. We have this length a, now we just need the blue point. So let's call this point at the top B for ball, I guess. And so the final point of the blue point, I guess we'll just say P, that's going to be, we're going to start at B here, and we're going to move in the direction of V, and we're going to move in the direction of V by the amount of A. So that's how, here's how this is going to look. So we're going to start at B, and then we're going to move in the direction of V, but only in the direction of V. We don't want the length of V, so we're going to divide out the length of V. What we do want is the length of A here. So we're going to multiply by, oh, actually I meant to do here, but yeah, we're going to multiply by h squared over the magnitude of V. And we have these two magnitude of V squared on the bottom. So we'll just write it like this. Great, so that is our solution. That is how to get the blue points on the sphere, these points here. And I will leave the code in the description, but basically what we just calculated is this line right here. Great, so if you made it to the end of the video, my assumption is that you kind of like math. And I recently created a Discord server for Roblox developers who like math. So I figure if you made it to the end, you probably might be interested in this server. So here's the link if you want to join. We're just a server of people who like math, who discuss math. If you just want to learn more math, we're there too. So that's that, and I hope this was helpful.